combustion. Now, first of all, what is combustion? What's the meaning of it? It refers to the process of burning of a substance or a material. The burning process, okay, where a substance is burnt is basically known as combustion. Now, the process of burning is known as combustion. It is a chemical process. In this process, a substance reacts with oxygen to give off heat. While burning, a substance reacts with oxygen and produces heat. The substance that undergoes combustion is called fuel. Some materials burn with flame like a candle, whereas some burn without a flame like a coal. Okay, some substances burning takes place with a flame, whereas some substances burning takes place without a flame. The substances that undergo combustion easily and produces heat is said to be combustible. Okay, those substances which undergo combustion easily and they produce heat are called combustible. Different substances catch fire at different temperatures. Some substances they catch fire at a slight low temperature too, but some substances we need very high temperature for them to catch fire. Then the lowest temperature at which the substance catches fire is called its ignition temperature. Okay, the lowest temperature means that temperature, the exact temperature at which a substance catches fire is called its ignition temperature. Okay, that temperature is called its ignition temperature. There are some conditions that are necessary for burning or combustion to take place. Some conditions that are necessary for combustion to take place. One is heat. Ignition temperature must be within axis. Okay, means that temperature. Okay, providing temperature to the substance, providing heat to the substance. Then there is fuel, an object in which an object to be burnt is important. Okay, that would be a fuel. And oxygen. A suitable amount of oxygen must be there. Okay. Now, any doubt in combustion? Okay. Hello, Anna. Good morning.
Good morning, ma'am.
I just taught combustion, which is the process of burning of a substance. This combustion is known as burning, and the three things necessary for burning to take place is heat, that is temperature, fire, then fuel, that is a substance which we will burn, and oxygen, that is present in the air. Okay, now next we have
Yes,
flame.
ma'am.
Yes, next we have flame. Can I have your videos on, Emma and Anna?
Ma'am, I'm just logging in from another device, so I'll be able to switch on my camera on that.
Okay, okay, Anna. Okay, flame. The substances which vaporize during burning gives flames. For example, molten wax rises through the wick and is vaporized during burning, and that forms flame. Okay, we know that a candle is made up of wax. When this molten wax gets vaporized, gets melted, and gets converted to the vapor through the wick, it is like vaporized and it forms a flame of a candle. Coal, on the other hand, do not vaporize, so it does not produce a flame. Okay, this is a composition of a flame. Okay, are different zones of a flame. Okay, different zones of a flame. Shall I show you English An English diagram?
Yes, ma'am.
Yes, ma'am.
Okay. We can see the diagram. The outer zone that is there, okay, blue in color, outer zone of complete combustion. It is also the hottest part. Then we have the middle zone of partial combustion, whereas which is moderately hot, and then the innermost zone of unburnt wax vapors, which is black, is least hot, and below that is the candle wax that is melting. Okay, you can see it in this diagram also. Okay, hottest part is the outside, moderately hot is the center part, and least hot is the centermost part. Okay, understood?
Yes, ma'am.
Okay, now light a candle and observe its flame carefully. Now introduce a clean glass plate or slide into the flame of the candle. Hold it there with a pair of tongs for about 10 seconds. Then remove it. What will you observe? A circular blackish ring is formed on the glass plate. It indicates the deposition of unburned carbon particles present in the luminous zone of the flame. Now introduce a portion of wire in the uppermost part of the flame. You will observe that this portion of the wire gets red hot. It indicates that the non-luminous zone of the flame has a high temperature. In fact, this part of the flame is the hottest part. Okay. If you if you put a wire, okay, in the outside of the flame zones, or like the outside part, okay, it will become red hot. That's the hottest part. Now, goldsmiths blow the outermost zone of the flame with a metallic blowpipe for melting gold and silver. They use the outermost zone of the flame for melting gold and silver. Okay. For the melting of gold and silver, the outermost layer of the flame is used. Okay, because it is the hottest part of the flame. Then we have firefighting. You must have seen or heard of fire breaking out in homes, shops, and factories due to the carelessness and faulty equipment. We have learned that there are three essential requirements for combustion. These are fuel, air, and heat. Fire can be controlled by removing one or more of these requirements. It is quite difficult to remove fuel from the site of fire, so the fire is extinguished by the following two factors. Now, what happens is that fire is fire that is combined takes place by three things. Like three things are necessary, three conditions are necessary, after which or in which this combustion takes place. That is your fuel, your fire, and oxygen, right? And what happens is when fire takes place and we have to extinguish it, we have to take out any of these like components from the equation to stop the fire. That is what is done. Now we have fuel, that is the thing that is burning. Now it's very hard to take out that thing that is burning. Okay. Like for example, a building is burning, so it's very difficult to take out the building, right? We cannot take out the building. So fuel is, it's very hard to take out the fuel from the equation. So what's taken out is the air, okay, or the like oxygen supply to the fire, or the fire, okay, or like the cooling of the combustible material. Okay, those two things are done to stop the fire. Let's read about it. Now, so the fire is extinguished by the following two factors. First is by cutting off the supply of air.
Ma'am, ma'am,
Mhm. Yes.
I have one, like, you're saying that we normally don't take out the fuel, right?
Mm-hmm.
So this situation I'm giving may just be a hypothetical situation that has never
Mm-hmm.
happened before. So let's say
Okay.
a fire broke out in the building. Okay, this
Mm-hmm.
fire was not a normal ordinary fire; it was a grease fire. So you could not spray water on it to extinguish it.
Mm-hmm.
The but you could cut the fuel out to ensure the fire doesn't spread.
Mm-hmm. If
And
we can cut the
and
fuel out,
ma'am,
then
we
it can be done. Mm-hmm.
we can cut the fuel out, ma'am. Like I think so. If we switch the entire electricity off in the entire building, we we will cut the fuel out, right, ma'am?
Mm-hmm. We'll be able to do that. If it is a grease fire and it is like we can switch off the electricity. Okay, it's gonna help to not for the fire to not spread. Okay, but like still not fully, not completely. Okay, just cutting off the electricity is not gonna completely stop it from spreading. Okay, so you need like fire extinguishers. You will need to extinguish the fire. Some people also use sand. Some people use blanket. If you know, if like a fire occurs, like, or if a fire starts burning on a gas cylinder, then people wrap it in a blanket and throw it. Okay, to cut off the air supply.
Ma'am, throw it where?
um, Throw it like they roll it off to an area where like people are not there, people are not around. Like throw it out of the house or roll it out of the house. Wrap it in a blanket and they roll it out of the house
Okay, ma'am.
so
And
that the
ma'am,
fire doesn't blow off. Yes.
in an apartment, ma'am, how will you roll it to an area where people are not there?
In an apartment, how will you roll it? You just like wrap it with a blanket and put it outside your like outside your flat. There is a little open area, right, where outside each flat, like
No,
rooms
ma'am,
are
we
there,
only we only have stairs.
only have stairs. Then you can put it on the stairs or take it towards the stairs or roll it up off the stairs, maybe. But putting it in a blanket first, nicely. Wrap it in a blanket and you can roll it up the stairs. So that is done with even humans. If a human catches fire, if a human catch fire, blanket is wrapped around them to extinguish the fire because the blanket cuts off the air supply on the
Ma'am,
oxygen supply. Yes.
ma'am, we could wrap a human with a blanket, ma'am. But because he's a human and not a metal cylinder, our metal won't burn that easily. Meaning, like, only after high temperatures, it will start to deform and the gas will get leaked.
Hmm.
But since the guy is a human and he's made of flesh, won't when the fire touches him, he start to get burnt?
No,
So,
no. Like
so,
fire will
so,
catch. You say.
so you won't have time to wrap an entire blanket around him and roll him like the cylinder. Like
You cannot.
when I was small, not small,
Mhm.
sometime back then, you have to drop and you have to roll.
Mm-hmm. Drop and roll, yes. Drop and roll is also done. Okay. Drop and roll is also done. And roll in the blanket is also done. But you don't like throw the person out. Okay. But like you wrap them in a blanket. Okay. And then they can like roll or like wrap them in a blanket. So that cuts of the air supply. Then drop and roll also is there. Like you drop on the ground and roll. That is also helpful when it is a person. Okay. Now,
Yeah,
anything
ma'am, but when you
else?
wrap the human being when they are on fire in a blanket, how come they're not getting burnt?
Because a blanket, it cuts off the air, you know, it cuts off the like oxygen that is a necessary component in burning. Okay, burning takes place
But still, when you
still when you
press the cloth to someone's body, you're pressing the fire also, right? Before it
Mhm.
gets extinguished.
Not a cloth, Anna. A cloth will burn. Okay, a cloth will burn, but a thick blanket. Okay, a thick blanket we are taking. Okay, and then we cover a person with it. So the oxygen that the person was getting from the air outside, it will stop that. The blanket, when it's covering a person, it will stop the air or the oxygen from reaching the fire, and the fire will be extinguished. That is why the blanket, because the necessary conditions are heat, that is fire, then oxygen, and uh, like object to be burned, that is your fuel. So we have to eliminate or we have to take out any one of these things for the fire to stop. Okay. By cutting off the supply of air, is the supply of air can be stopped by covering the burning solid fuel with oil, sand, and blanket. Okay. These cut off the air supply. If sand is also, if there is an object or place, sand is also put to extinguish the fire. Okay, to stop the air supply. Then, by cooling the combustible material below its ignition temperature. See, we know that fire only sets or fire only occurs when the temperature, when the temperature reaches a burning point, when the temperature reaches a point where it will be ignited, okay, or it will start burning. So it is cooled down. So it is cooled down below this burning temperature for the fire to cut off. For the fire to cut off, it is cooled down below this ignition temperature. Okay. Now, water is the most common fire extinguisher. Water cools the combustible material below its ignition temperature. This prevents the fire from spreading. Water vapors also surround the combustible material, helping in cutting off the supply of air. But water works only when things like wood and paper are on fire. Okay, things like wooden things and paper are on fire. If electrical equipment is on fire, water may conduct electricity and harm those who are trying to douse the fire. Water is also not suitable for fires involving oil and petrol. Okay, oil, petrol, electricity, water is not used because water is heavier than oil, so it sinks below the oil and oil keeps burning on top. For fires involving electrical equipment and inflammable materials like petrol, carbon dioxide is the best extinguisher. Carbon dioxide is used, okay, when we have fires of
Ma'am,
electricity. Yes.
ma'am, do you know, like, when the water gets floating on top of oil, what happens is, so the oil burns on fire and the water carries the fire. So the reason they will
Hmm.
still not use water is because the fire will spread out more because of the density.
Mm-hmm. Yes, Abraham, absolutely. That is true. water will carry fire if you put like water on a fire that is caused like by oil or like in an area of oil. It just carries it more. The water will carry more fire, and the fire will spread. So when oil, petrol, yes, Hannah.
Um, they usually don't add water to extinguish fires and forest fires. They just go ahead of the fire and burn all the plants so that the fire doesn't continue.
They go ahead of the fire and
They put fire to the plants. It's going to catch fire on, and so if you do that, the fire doesn't catch on to that because there's nothing left to burn, and it just extinguishes on its own.
it just extinguishes on its own. Forest fires is a thing, okay, that like starts on its own and extinguishes on its own. Forest fires, okay, but like wildfire, okay, for the fire caused by any activity by humans or anything, for wildfire, it is like extinguished, and it is also like very harmful because the fire spreads quickly. And if it's happening in forest, okay, it will happen very quickly from tree to tree. It will start burning, okay, and the wood will start burning, and water is used actually for extinguishing the fire, for extinguishing a wildfire, because wood cannot wood is, we can extinguish the fire of wood by water, so it can
Ma'am,
be. Yes.
I think what Emma's saying is that she's not denying the use of water. She's just basically saying water is used less is because when the forest catches on fire, ahead of the forest, the fire people will go, and what they do is they will burn all
The
the like.
plants the fire is going to burn. Anyways, it's already burned. So the fire which is spreading, it can't burn anything again because it's all the leaves and grass it's burning is already burned.
Yes, ma'am, I've seen
Another
a video of that happening actually.
You've seen that happening, or what? Say again.
Not in real life, but like on like videos. Basically,
Yes,
they
ma'am.
burn the so wherever the flyer will come next and catch it, they put a bit of fire just to burn that area so that the fire cannot spread after. They don't waste much water.
Okay, okay. Now I understand what you are mentioning. Mm-hmm. Okay. So the fire that is like the fire is moving in a wildfire, and the area that the fire is going to come next to, they burn it so that the fire can like come there and it doesn't burn that and move forward.
Yes, ma'am.
That's what you're mentioning, right?
Yes, ma'am.
Yes.
Basically, no area more to burn, so he has to like the fire has to go
Fire
out.
has to stop there because it doesn't have like space to move forward and burn more and then move forward.
Yes, ma'am.
Yes. Yes, Amayana, that is right. It is done. Okay. Sometimes it is done in forest fires and wildfires that the area where the fire is gonna come is burned so that the fire like stops there because it cannot burn and move forward. Okay, that is right.
ma'am, the technique is called black burning.
Technique is called what? Black burning.
Yeah, ma'am.
Yes. Yes, the technique is called black burning. Now, it's quite interesting, this technique. It like it's logical also that it just stops the moving fire, the spreading of fire. Yes. Now we were talking about the electrical fires, okay, like the fires involving electricity. We cannot put water on it. So what is done is that carbon dioxide is used. Okay, fire extinguishers are used which have carbon dioxide. Okay, and this carbon dioxide also works as a blanket to cut off the air supply, oxygen supply, and extinguish the fire. Since the contact between fuel and oxygen is cut off by CO2, the fire is controlled. Okay, it's a red cylinder like this. That is a fire extinguisher. You must have seen a red cylinder to get the supply of carbon dioxide. Carbon dioxide is stored at high pressure as a liquid in these cylinders. When released from the cylinder, it expands enormously in volume and then cools down. So it brings down the temperature of the fuel, brings down the temperature of the fuel, okay, cuts off its air supply, and that is why fire extinguishes. Okay. When the knob of the cylinder is opened, soda reacts with acid and pours the mixture of carbon dioxide and water on the fire, and the fire is extinguished. Okay. Any doubt in this portion? No? Okay. Now we have fuel, a substance which have energy stored in them in different forms and provide energy are known as fuels. These substances, they have energy inside them and they also provide energy if they are burned. Okay, they also provide energy. They are called fuel. A good or ideal fuel is the one which is readily available, means we can easily get it. We can get it for low price, which is cheap, which burns easily in air at moderate rate, okay, and produces large amount of heat and does not leave behind any undesirable substances. This is what a good fuel is, okay, or what an ideal fuel is, which follows all of these conditions. That would be your good fuel, ideal fuel, okay. We obtain energy from different sources. This we know. It can be natural sources, it can be artificial sources. We're gonna see some natural sources of fuel and we will see some artificial sources of fuel. Natural sources of fuel. We get coal, petroleum, and natural gas from different natural sources. These are the three major natural fuel: coal, petroleum, and natural gas. Okay? These are the three major natural fuel. If we continue to use them with present faster rate, the reserves of oil and natural gas present in the earth will exhaust in the next 20 to 30 days. These fuels are also known as fossil fuels because it is considered that they were formed from the dead remains of living organisms or fossils. Okay? Because they were formed from fossils, we say that they are fossil fuels. Coal reserve found as coal mines is limited. In future, the entire coal will be used up and this natural source of energy will be exhausted in the years to come. Coal is a substance which contains chemical energy and this energy is converted to heat on burning. You know that coal produces heat when it is burned. Then other sources like liquid petroleum were also formed when animals got buried under the soil millions of years ago. They also contain chemical energy, which gets converted to heat and light on burning. That is liquid petroleum. Then we have all the fuels mentioned above burn in the presence of oxygen. They burn in the presence of oxygen, produce different gases like carbon dioxide and sulfur dioxide. And all these gases pollute the atmosphere and pose threat to our health also. The use of liquid petroleum is for running buses, trucks, trains, aeroplanes, cars, scooters, etc. Kerosene is used for lighting and getting heat energy. The comparative study of all these fuels suggests that Different fuels have different thermal efficiency. Okay, means different fuels have different ignition temperature at they get at which they heat up, different different capacity of producing heat. Okay, some fuels produce more heat, some will produce less heat. Okay, so this is about natural sources of fuel. Okay, the natural sources of fuel that we like get them naturally from the environment. Artificial are the ones which are man-made. Okay, it's produced by humans. So tomorrow, Monday, we are going to do coal and petroleum. Okay, which are the two natural sources. In this lesson, we majorly have the natural sources. Artificial sources are not really covered. Okay, but I'll tell you a little bit about it. Tell you about it in brief. What are the artificial sources? What are their uses about? Okay. Okay. I have yeah. I have like not received your science test papers.
Yes, ma'am. I'll send it.
Yes, ma'am, I finished. I'll submit it now after class.
Submit it now, okay? All of y'all. Submit it now. I need your science test papers. And I'll be sending maths test papers in a bit. Okay. Okay, so that's all for class today, and now we are going to meet on Monday. Bye, all. Have a good weekend. See you on
Bye,
Monday.
ma'am. Thank you, ma'am.
Bye, ma'am. Thank you, ma'am.
Ma'am, no maths today.
No maths today because test is there now.
Okay, yes, ma'am. I'll send you the exam. I just need to finish one question. Then I'll send
Okay.
it to you.
Okay. Finish and send it to me by today. Okay.
Okay, ma'am.
Bye, ma'am.
Okay. Bye. Bye.